Hey there. Have you ever stopped to wonder how a message you send can zip across the globe in just a few seconds? It feels like magic, right? But it's not. It all comes down to a small, often ignored box. So today, we're going to pull back the curtain and see exactly how a router works. I mean, seriously, think about that for a second. An email from Tokyo to Toronto, that's a journey across continents and under vast oceans, and it happens millions of times every single second. It's a pretty mind-boggling feat of engineering that we just take for granted every day. Well, the secret lies with this little box, the router. It is the unsung hero of the entire internet. Think of it as a digital traffic cop, tirelessly directing every single piece of data to its correct destination, making sure our online world just works. Okay, so to really get how a router does its job, we first need to meet the star of our story, the data packet. You see, the internet doesn't just send your email or a video as one big file. Nope. Instead, it chops it up into these tiny, manageable pieces. So, a router doesn't see your vacation photos or that important work document. It only sees these little messengers called data packets. A single email can be broken down into hundreds of these packets, and each one gets sent off on its own little journey across the web. So, how does a packet know where it's going? Well, each one has a digital shipping label attached. Just like a real package from Amazon, it has a from address, that's a source IP, and more importantly, a to address, the destination IP. And for a router, that destination IP address is the most critical piece of information in the entire universe. Okay, so a packet has just arrived at the router's doorstep. What happens next? Let's dive inside the router's brain and see how it makes these incredible split-second decisions that guide all of our data. At the very heart of every router is something called a routing table. And this slide, it illustrates its job perfectly. It's basically a map for the entire internet. But instead of cities and roads, this map shows networks and the digital pathways that connect them all. And what's fascinating is how simple this map really is. It tells the router three key things: where the packet ultimately wants to go, the destination network, the very next router it should jump to, that's the next hop, and which physical door to use to send it on its way, the interface. And get this map isn't static. Routers are constantly chatting with each other, updating their maps to make sure they always know the fastest, most efficient routes available at any given moment. The whole process is just unbelievably efficient. First, it reads the destination IP. Second, it glances at its routing table. Third, it picks the absolute best path. And finally, it forwards that packet to the next router in the chain. It's just a continuous, lightning-fast cycle of reading, checking, selecting, and forwarding. And here's the kicker. That entire four-step process, it happens in a matter of milliseconds. That's what makes the internet feel so instantaneous. It's an absolutely incredible feat of engineering. Now, for a global system like the internet to actually work, every single device has to follow a common set of rules, right? This makes sure that hardware from all these different companies can all speak the same language. In the world of networking, that rulebook is called the OSI model. Let's see how routers fit into this. The OSI model has 7 different layers, and each one has a very specific job. But for a router, the most important one by far is layer 3, the network layer. As you can see right here, this is where it spends most of its time. This is where the big decisions about logical addressing and path selection happen. It's the router's main playground. So here's the key takeaway. Think of it like this. Layer 3 is where the router makes the big picture strategic decision using that final destination IP address. But it relies on layer 2 for the immediate local delivery to the very next device in the chain. And it needs layer 1 to physically send the signals over a wire or through the air. It's a real team effort across all these layers. So, while finding the best path is its #1 job, a modern router is actually a pretty versatile device. It juggles several other really critical tasks to keep our networks humming along smoothly. Yeah, routers do way more than just forward packets. They create boundaries between networks to boost performance and security. They manage traffic to prevent digital gridlock by prioritizing important data, and they can even act as a first line of defense with security features like a firewall. They really are the Swiss Army knives of the networking world. Now, the router blinking away on your home is a totally different beast from the ones that power the internet's backbone. Your home router is an all-in-one gadget, right? It's a router, A switch and a wireless access point all rolled into one. An enterprise router, on the other hand, is a specialist, built for one thing: high-speed routing of absolutely massive amounts of traffic. So, let's bring this all together. It's pretty clear that this small, often forgotten device is quite literally the engine that drives the entire internet. This analogy just sums it up perfectly. A router is like a totally impartial traffic controller. It has no idea what's inside the packet, and it doesn't care. Its only concern is where that packet is going. It just finds the most efficient route and sends it on its merry way. And that's really the bottom line. It's not an exaggeration at all. Every single email you send, every video call you make, every website you visit, it's all made possible by a global network of these incredible devices, all working together in perfect harmony. So I'll leave you with this thought. The next time you hit send, just take a second to think about the incredible journey your data is about to take. It's a high-speed relay race across the entire globe, and it's all thanks to the humble router.